Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. In this video, I would like to talk some more about the map generator, which I've already demonstrated in a couple of videos. If you've been following this series, you might remember that last time that I talked about this program, we had it set up so that it would generate orientations of land which displayed a variety of possibilities of how they were oriented, whether it roughly ran sort of east to west or northeast to southwest or whatever. But it didn't have all the possibilities. So, for example, we might find that we got land that sort of ran roughly east to west. So we might have, the equivalent of a mountain range or a sea or whatever, an area of the same height, which was oriented roughly east to west. Or it might be off from east to west by up to about 45 degrees. So it might run from sort of southwest to northeast, for example, or similarly northwest to southeast. But you wouldn't get land that ran roughly north to south. Well, I've updated the program again, and as you can see, now we do get land that runs north to south. And in fact, we should have the possibility of having any sort of orientation. So we can still get all of the possibilities that we had as of the previous video, but we've now sort of added the possible directions that weren't impossible, but were certainly very unlikely with the previous algorithm. So I'll just run through a couple because it doesn't take very long, and you can see that if you've seen the previous one, this is another one that goes sort of roughly north to south. You can see that we're getting results that we wouldn't have gotten with the program as it was. So I'll just show you a couple more of those, and then I'll show you how it works. Maybe show one more. Okay, so let's get into the code. So before we start going through that line by line, I'll tell you the broad idea. The way that the program was as of the previous video, about the lines of similar height could run in about half of the possible directions. So if you imagine a line running east to west, and then you turn that line, let's say clockwise about 45 degrees, and then you imagine the line east to west again, and then turn it anti-clockwise 45 degrees, well, that will cover about half the circle. And those orientations were likely to come up, and the other orientations, the missing bits not covered by that, had more or less a zero chance. Technically, probably not a zero chance, but effectively a zero chance of coming up. So how do we get those missing pieces, those missing possibilities? Well, broadly, what we do is half the time we generate the map and display it turned 90 degrees. So if the code generates a map that runs east to west, then half the time we turn it 90 degrees. Well, half the time that'll make that land run north to south. And of course that's similar with if it's, let's say, 20 degrees clockwise, from east to west, well, half the time we'll turn it 90 degrees and that'll make it 20 degrees clockwise from north to south. So those missing possibilities will be filled in by that. Because the map is not square, we have it, it's twice as wide as it is high at the moment. We have to decide, because we don't want the map to be an odd shape. Of course, if we just made 100 by 50 grid and turned it 90 degrees, well, it'd be 50 by 100. It'd be a different shape, and it would be easy to say, well, you've just turned the map 90 degrees. It would look weird if they were different shapes each time. So what we have to do is firstly decide whether we're going to turn it 90 degrees. Then if we are going to turn it 90 degrees, we swap the dimensions. So if we're going to turn it 90 degrees, instead of making a 100 by 50 map, we make a 50 by 100 map. And then when that is turned 90 degrees, it'll be a 100 by 50 map again. You'll see what I mean as we go through the lines. I will say before we start, there's a fourth passage, because we have some code that is identical in this passage and this passage. And as usual, when you have identical code, the most efficient way is usually to have that code in a separate passage and include have an include command that calls that passage in the two or more places where you're using the code, rather than type out the code identically. So let's just go through the flow of the go through this in the order in which the program will go through it, which is initialize, generate map, print map. I won't talk about everything because I've talked about most of this before. I'll only talk about the changes. So we have the dimensions. Now we have this new variable called turn, $TURN, and it's set to a random number, 0 or 1. Now, you probably guessed, well, that's whether we're going to turn it or not. If it's 0, if this has a value of 0, then the program proceeds exactly as it did as of the previous video. And if it has a value of 1, then we're going to do the turning. So we set that. That's the sort of almost the first thing we do. Then we include this new passage, which is swap xy. Let's look at that. Swap xy does exactly what you'd expect from the title. It swaps the values of the x and y variables. Normally when I do programs, I use x and y for temporary variables. So what x and y are refers to lots of different things. That's not true for this one. X and y refer to the dimensions of the map. So we swap it using this set of 3 commands, which we've often seen before, where we have one temporary variable, in this case z. We set z equal to the value of one of them, in this case x. We set that variable equal to the value of the other variable that we want to swap, and then we set the second variable to the value that we've stored in this temporary variable, which is the original value of the first variable, if that makes sense. So if you follow the logic of this, if you set, give x a value of 100 and y a value of 50 or whatever, if you follow what will happen when we set z equals x, set x equals y, and then set y equals z, what will happen is that x and y will swap their values. So 100, 50 becomes 50, 100. The only other change on this page is that when we're setting up map, we used to have a loop that went from 1, and this used to go, this used to say z is less than or equal to x, and then z plus plus. Now it says z is less than or equal to math.max bracket $x, comma $y, end bracket. What that means is the maximum value of out of the list in the brackets, which has to be at least two variables. In this case, it is two variables. It's x and y. So this goes up to whatever's higher out of x and y. Now, because x is higher in this version, changing it from z is less than or equal to x to z is less than or equal to the higher of x or y isn't going to make any difference. But this would make a difference if we had dimensions where y was bigger than x. In other words, if we wanted to create a map that was taller than it was wide. Now that's unusual, of course. Maps, you would probably expect them generally to be either square or wider than they are high, at least the ones you see on a computer. Because of this, because computer screens are wider than they are high, we tend to create displays, including maps, that are wider than they are high. But there's nothing, unhistorical or unusual in the general world about a map that is higher than it is wide. In fact, maps on an atlas generally are higher than they're wide because of the fact that a page is higher than it's wide. So, of course, someone modifying this might want to change the dimensions, or they might want to allow the user to input the size that they want, and this change ensures that you won't get an error if you happen to have y that is higher than x, even though that's not something that happens with the program as is. This is just setting up map to be a two-dimensional array. If we have y higher than x and we hadn't done this, we'd get errors eventually when we looked at the higher slots of map, because we wouldn't have set them up, because we would only have gone up to the value of x in this initial loop. Okay, so that is identical to as it was, except for those two and this little change here. Then we generate the map. This is actually identical to how it was before. It's just that half the time, because of turn having a value of 1, or overall roughly half the time, because turn will have a value of 1, these values that are going up to y and up to x will be different to what they were when there was no chance of swapping them. But otherwise, we create this map exactly as we did before. And then, when we print the map, there's only one change. There's two changes. One, we have this other include swap xy. So let's say that turn is 1, because swap xy only does something if turn is equal to 1. If turn is equal to 0, then this doesn't do anything. It goes there. It says if turn equals 1, well, turn isn't 1, so I'm not going to execute any code. So it's only worth thinking about what happens if turn is 1. Well, what happens if turn is 1 is that first, or initially, we had x is 100 and y is 50. Then we swapped them, so x is 50 and y is 100. And now we're going to swap them again. So, of course, that's swapping them back. So whether turn is 0 or 1, we now have these original values again. We sort of, if turn was 0, they were never anything else. And if turn is 1, they were swapped and then swapped back. But how's that going to work? If we're trying to print a 100 by 50 map, but we've generated a 50 by 100 map, how are we going to make sure all the squares are displayed? Well, that's what this change here is. If turn equals 1, we do this, which prints a square of a particular colour. The colour is based on the height of a particular square of the map. And if turn does not equal 1, we do exactly the same thing. So what's the difference? Well, the difference is here. If turn equals 1, we refer to $map y2 x2. So notice that the map stuff is stored as you might expect coordinates to be stored, which is x and then y. And here we are referring to map with the y one first. And that's the difference. If turn equals 1, we refer to map y2 x2. And if turn does not equal 1, we do what we did originally, which is we refer to map x2 y2, the way you might expect. And because, well, if turn equals 0, then it just works exactly as it worked previously. If turn equals 1, because we're looking at map y2 x2, that's how we can display a 50 by 100 map as a 100 by 50 map. All we do is just swap the x and y coordinates, and then in effect we have a 100 by 50 map instead of what it really is stored as, a 50 by 100 map. We're effectively rotating at 90 degrees. Actually, I think it's the equivalent of rotating at 90 degrees and then flipping it over. It works out, but the point is that it displays this map that's the wrong shape. It displays it as the right shape. And because, let's say, let me sort of draw out an example. Let's say we have a map. Let's say that turn is equal to 1. We might have a map that goes from here to here to here to here. So that's a map that's sort of taller than it is wide. I know the proportions aren't right because, I mean, it should be 4 squares by 2, I suppose, to be the same proportions. But the lay of the land might be roughly east to west, something like that. Well, when that's displayed, east to west will become north to south. Or it might be mostly east to west, but sort of trending slightly north. Well, when that is turned around 90 degrees, it'll be mostly north to south, but trending slightly east to west. And so we have, because turn is only equal to 1 half the time, we have these new possibilities, but we don't get rid of the old possibilities. Half the time it will just be one of the angles that we had before, and half the time it will be this new set of angles. And so if you didn't know how the map was constructed, if you didn't know the code, if you were just looking at it as a normal user, I don't think you'd notice any particular sort of tendency for the land to lie at particular angles. We've sort of created enough variety that it's probably not completely unbiased. I would imagine you probably, if you analysed it, if you looked at 100 possibilities, you'd probably see that certain things were more likely. But a casual viewer just looking at 1 or 2, just playing a game that involved this, would probably not notice anything and would see that, sometimes you had north to south, sometimes it was east to west, sometimes it was at an angle, and it looks like it can sort of have, everything, just as in the real world, land doesn't orient itself in particular directions. So we've made a more sort of varied and realistic looking set of outputs, which of course is what you want when you want to generate a map. That's one of the things that we're looking for is realism. And we've also done it with quite a lot of speed, which is another thing that we want when we're doing anything on a computer, but particularly things that involve lots and lots of data points, like a map of any size. Twine is unfortunately very slow, compared to a lot of other programs. It has a lot of virtues, but great speed is, I don't think, one of them. And so anything we can do that's really quick is really good in Twine. There's no shortage of algorithms, like generating a map without having a bias towards particular lay of the land is not difficult. There's a dozen algorithms for making maps. The problem is that the algorithms that you will find when you go searching for, map generation algorithm or something like that, you will find no shortage of results. But when you translate them to Twine, you might find that they're very slow. The virtue of this program is that it now, at least, it doesn't have an obvious bias towards particular orientations of land, and it does it a lot more quickly than you might find with other algorithms. So I'll leave it there. In my next video, I will be getting back to the subject of most of my recent videos, which is the coding the combat system for a viewer's game, and I'll probably stick with that. Well, I will stick with that until it's finished, but I mean, I probably will, all the videos will probably be on that until it's finished, unless I think of some other significant improvement to this or something else that I want to show you. But for now, I hope that was useful or interesting to at least some of you, and I hope you will tune in next time.